If you want to see how a house is built, you look at its framework. On Exploring North Carolina, we will show you how this state is held together by the rock forming the skeleton of North Carolina.
This program is made possible by the North Carolina Aggregates Association, with programs to improve public understanding of mining and the use of mineral products. Thanks also to the members of State Employees Credit Union to celebrate and promote awareness of North Carolina's natural resources. Exploring North Carolina is produced in association with the North Carolina Museum of Natural Sciences and UNCTV.
I'm 80 feet below modern-day sea level. I'm also standing on the bed of an ancient ocean formed between 30 and 50 million years ago. I know this because of the limestone around me, made of sea creatures. I'm in the Martin Marietta Quarry at Castle Hayne, North Carolina. Today on Exploring North Carolina, we're going to start in this quarry near the Atlantic Ocean and visit quarries across the Piedmont. We're going to end up near Black Mountain at the Blue Ridge Parkway. In the process, we're going to see different rock that make up the skeleton of North Carolina. Our guides today all work with quarries across North Carolina. At Martin Marietta's Castle Hayne Quarry near Wilmington, we met with Sam Johnson, Director of Exploration. In Princeton, North Carolina, we visited with the manager of Lehigh Hanson's quarry, Don Harvey. Near Raleigh, at the Knightdale Quarry of Wakestone Corporation, we worked with the company's chief geologist, David Lee. East of Charlotte, at the Gold Hill Quarry owned by Vulcan Materials Company, we met with geologist Tom Carroll, who is also Director of Development for Vulcan's Mideast Division. Finally, in Black Mountain, a few miles east of Asheville, at the Hedrick Industries Quarry, we worked with Jason Connor, Vice President of Land Management. On past episodes of Exploring North Carolina, we told you about mining gold and coal in the 19th and early 20th century. Today, arguably the most important mining across our landscape is the mining of aggregates, the rock products used in our buildings and transportation infrastructure. Under the cypress and longleaf pine forest near Wilmington is the youngest part of North Carolina's stone skeleton, the limestone at Castle Hayne. Sam Johnson explained its location and how it was formed.
The Castle Hayne Quarry here is located about 20 to 25 miles inland from the coast. We're located about 12 miles north of Wilmington. The quarry itself encompasses over 1,000 acres. Today we have about 300 acres of active mining area. Here at the Castle Hayne Quarry, we're actually mining a limestone. It's known as the Castle Hayne Limestone Formation. The Castle Hayne Limestone Formation began forming about 50 million years ago. It was the sediment of seashells, fossils, and other marine organisms. And that settling process, deposition, lasted about 20 million years to give us the thickness of the limestone that we have here today. We mine this limestone for the simple reason that it meets the quality parameters that we need to meet DOT specifications for construction aggregate. This aggregate is used extensively in the Wilmington area for concrete, for asphalt, essentially anything in the infrastructure that we build, including commercial and residential development.
I asked Sam how experts are able to pinpoint the age of this limestone formation.
We know the age of the Castle Hayne limestone formation based on those fossils and shells that we can still see today. The fossils are indexed and have been cataloged, and they only occurred in history during that 30 to 50 million year ago time period. This is the Eocene time period. So finding those shells and fossils today, we know that this formation was formed during that time period.
You might think I'm in one of North Carolina's deep mountain gorges with the steep rock wall behind me, but I'm actually 30 miles east of Raleigh in the Hanson Aggregates Quarry near Princeton, North Carolina. At this location, I am 380 feet below the Earth's surface, and I'm also 250 feet below sea level. This quarry has a footprint of roughly 100 acres, and at 380 feet deep, you could fit most of downtown Raleigh in this quarry and only see the tops of a few buildings.
Don Harvey gave us an overview of North Carolina's skeleton, where the coastal plain ends and the Piedmont begins.
Princeton Quarry is located about 100 miles west of Wilmington and about 30 miles east of Raleigh. We're out Interstate 70, just off of the 95 corridor. Currently, the quarry is about 100 acres in diameter. The quarry depth at its deepest is 383 feet. The type of stone here at Princeton Quarry is a metamorphosized rhyolite. We are exactly on the fall line between the Piedmont and the coastal plain region. So we have everything in this quarry, basically from limestone to quartz to sand. It's all here on one layer or another.
The Hanson Quarry at Princeton is unusual in that several different rock types are found at the same location, but one is much older than the rest.
The stone here at Princeton Quarry is approximately 500 million years old. It's part of an ancient archipelago of islands, volcanic islands. That's why we had the metamorphosized rock here. It was all ejected from a volcano over 500 million years ago. And so the area that we're down now hadn't seen light until we uncovered it in 500 million years.
Even though the quarries across North Carolina are often owned by different companies, they make up a network which provides stone products in a radius of approximately 40 miles, unless the stone product is unique and needed at a distant destination.
I'm in Wake Stone Corporation's Knightdale Quarry. I'm 260 feet below the road above. The rock around me is granite. At other quarries around North Carolina, you'll see other rocks, greywacke, rhyolite, and gneiss. All of these rocks make up North Carolina's skeleton, and these rocks also tell us where North Carolina came from and how old each of its parts might be.
I live in Raleigh near Knightdale and often drive past the quarry. But unless you have a reason to visit the quarry, you probably wouldn't know it was there. David Lee described the location and the size of this operation.
We're in the Knightdale Quarry of Wake Stone Corporation. The Knightdale Quarry is located just on the west side of the town of Knightdale in eastern Wake County. We're about 10 to 12 miles from downtown Raleigh, currently about 260 feet deep. Occupies somewhere on the order of 200 acres of land for the pit operation itself.
Even though we are only 30 miles from the Princeton Quarry, the rocks found in Knightdale are different. A good example of how North Carolina's underlying foundation, its skeleton, changes as we cross the state.
Here at the Knightdale Quarry, we are quarrying a stone known as the Rollsville granite. It's a portion of the Rollsville batholith that was emplaced within the Earth's crust some 300 to 320 million years ago. It is a granite. It contains feldspar quartz and biotite mica. Keep in mind that this rock formed at a very violent phase in our Earth's history, when the continents were moving around, when the African continent collided with the North American continent. Tremendous forces, pressures, and heat were generated during that collision, and it resulted in the textures that you see in the rock today.
The next piece of North Carolina skeleton at Gold Hill, between Charlotte and Salisbury, was shown to us by Tom Carroll of Vulcan Materials Company.
This quarry is located about 40 miles northeast of Charlotte, North Carolina, in the northeast corner of Cabarrus County. It's in a part of the state that's referred to as the Carolina Slate Belt. It's got a very unique geology here. It's located near the community of Gold Hill, thus the name of the quarry, the Gold Hill Quarry. The quarry is situated on about 550 acres, of which about 150 acres is in the active quarry operation. Current operations are about 150 feet deep, but given the land size that we've got, we can go substantially deeper than that. This quarry is situated in the Carolina Slate Belt, and it's known for metavolcanic rocks like tuffs, argillites, rhyolites, lava flows, things along those lines. The rock that we particularly quarry at this specific location has a meta-tuff or a meta-argillite, meaning they've been slightly metamorphosed. But they're interbedded, and you'll see that when you observe other places in the quarry, you'll see the interbedding of those two different types of rock.
If you think that all aggregate rock is the same, then a visit to the Gold Hill Quarry will change your mind.
What's so unique about this particular facility, and Vulcan's got over 300 facilities across the United States, but this one actually, the meta-tuff and the meta-argillite, we produce both a construction aggregate, which you'll find at most other quarries in the state. That's used to build homes, roads, bridges, goes into asphalt, concrete. But the one thing that makes this particular deposit very unusual is this meta-argillite. We actually selectively mine that and send that to our next door customer, and they put it through a kiln, heated up to over 2,400 degrees, and the rock actually pops. The best way to describe it is kind of like popcorn, and it makes it into a lightweight aggregate. The significance of that is the rock maintains its original strength and physical characteristics, but it significantly reduces its specific gravity.
And what that means is that uncooked meta-argillite sinks, but heated or popped, it floats. But why would anyone want lightweight rock that floats?
For most quarries, they ship product generally within 20 to 40 miles of the point of production, unless two things occur. There's no naturally occurring aggregate in the area that the product is needed, or in a situation where the rock is so unique that it has unique properties that's in demand for other types of construction. And it allows people to build massive structures and not use as much steel. So you can build a high-rise even taller, or a bridge with a longer span, or even offshore drilling platforms.
We began this program near Wilmington, North Carolina, with limestone, 20 to 30 million years old. And we crossed the Piedmont and saw other rock at different ages. Now, in the Hedrick Industries Quarry near Black Mountain, North Carolina, 400 miles from Wilmington, you're looking at the rock of the Appalachian Mountains.
At the Grovestone Quarry, we met Jason Connor, who showed us a much older part of North Carolina's skeleton in the Appalachians.
Grovestone Sand is located about 10 miles from Asheville. and we have about 1,600 acres, and we're located in the Black Mountain area. The material here is a metagray wacky that dates back around 700 million years in the Precambrian age range. The metagray wacky is made up mainly of kind of medium grain to coarse grain quartz, feldspar, micas, a little bit of hornblende, and feldspar. The metagray wacky at this location is found primarily through the entire kind of Appalachian area, similar to what you would find at Mount Mitchell and within the Black Mountains.
When you drive in the mountains of North Carolina, the roads are often cut through rock, but you still need rock aggregate from quarries to build roads and other infrastructure.
A lot of the products from this site go into the road building. We've used, our products have been on I-40. We helped construct Old Fort Mountain, I-240 going into Asheville, most of the roadways within the city of Asheville. So those are some of the larger products. So usually when you're in Asheville, you're riding on our products. We've done the spillways at the North Fork Reservoir and also the Bee Tree Reservoir, located a little bit outside of Asheville.
No matter what quarry we visited across this state, we were always amazed at the size of the trucks, loaders, and spray trucks used to keep down dust. But more importantly, we were impressed by the skill of the operators, whose movements appeared choreographed. At all quarry operations we visited, the operators strive to eliminate dust in the air and sediment in the water, and to create suitable habitat for wildlife.
Another thing we do to help control noise is we leave natural buffers around our property. Up to 200 feet, we'll leave the native trees, the bushes, the pine trees, whatever we have that's native to the area, we'll leave that buffer, and it helps mitigate noises that we generate during the production process.
For noise abatement, we've also instructed our loaders when they're loading a piece of equipment to try to back into the face of the active pit, and that keeps the noise from projecting out into the community. We also have a very mature woodland area that also helps with that buffer and kind of absorbs that sound while we're operating. The site's unique in that we do have such a large buffer within this footprint of our mine site. And then that buffer helps us to reduce the noise. Dust gives a lot more vegetation to filtrate out any potential sediment that may leave the site. Our goal at this location is to have zero dust and zero sediment leave this facility. We also are fortunate enough to have some wildlife corridors due to the proximity of the two reservoirs. And that allows us to have a significant wildlife population, whether it's bear, to foxes, deer, turkey, to hawks and other various migratory birds that come in and out. And we also have good fishing areas with the water and the streams that we have located on site.
We were impressed by ponds and especially the bird life found near quarries. But in one quarry buffer, we were dazzled by a display of butterflies, pipevine swallowtails, having a puddle party. With the massive equipment and steep rock walls, we wondered about safety. But in every quarry we visited, safety was paramount.
Probably one of the biggest misconceptions about this industry, the aggregate industry, is that for some reason people believe that they're an inherently risky operation. The fact of the matter is we have a strong culture of safety. And an example of that commitment is we've got a number of operations that have gone 25 years or more without a lost time accident, and numerous that have received awards from state and federal agencies.
The quarry industry, the mining industry in general, is a highly regulated industry, both from an environmental standpoint and also from a safety standpoint. All miners, when they come to work in the quarry industry, have to go through 24 hours of new miner training, on-the-job training. And then annually, each miner has to receive 8 hours of refresher training to learn about all the new safety aspects of their job.
Our safety record here at Princeton is exemplary. I want everybody to go home the same way they came in. We have a lot of policies in place to help that, and we have a lot of participation from the employees themselves. We wear these orange shirts so you can be seen anywhere at any time, hard hats, safety glasses. If you're working out in the plant, you're required to wear gloves, steel-toed shoes to protect your feet. Everything is controlled as best we can to make sure that people are safe on our property.
Most quarries use explosives to break up rock formations. At the Lehigh-Hanson Quarry near Princeton, officials allowed us to film an explosion from a safe distance. There was little sound, no vibration, and surprisingly little dust. You've probably wondered what is going to be done with giant holes, often several hundred feet deep, near North Carolina towns and cities. Our quarry guides helped us to look into the future.
All mine operations have to have a reclamation plan that speaks to what happens to the property once the quarrying stops. Typical uses for rock quarries of this nature could be a water supply reservoir for the municipality to which all that stone has been supplied over the years.
Another unique use is an example that's coming to fruition in Winston-Salem, North Carolina. The city of Winston-Salem, based on a donation that Vulcan made to them a number of years ago, is using their old Piedmont quarry to become the quarry park in the city of Winston-Salem. It's going to be integrated into their biking and hiking trails and become a focal point of the city. They can become reservoirs, which is probably the next 50 to 100 years are going to be very sought after.
Princeton Quarry is close to being 50 years old now. By the time it is done, it will be in excess of 100 years old. So we have at least 50 more years to go. Johnston County is looking at this site actually as a water reservoir when it is finished. They need more storage for the growing county, and this is one of the areas that they've tasked to look at for that storage. The quarry right now is 259 feet below sea level. The approximate depth when we get done is going to be 550 feet. And once we get down there, this quarry will hold quite a bit of water.
So how can a quarry 200 acres in size hold as much water as, say, a 3,000-acre reservoir? Let's do the math. Water is often measured in acre feet. 1 acre of water, 1 foot deep. A 3,000-acre reservoir averaging 20 feet in depth will hold 60,000 acre-feet of water. A quarry with a 200-acre footprint that is 300 feet deep can also hold the same 60,000 acre-feet of water. Today, we hope that you have a better understanding of the stone skeleton beneath your feet and how quarries provide a window into North Carolina's distant past. On Exploring North Carolina, we appreciate quarries because quarries tell us where we came from and what we are made of.
They also provide the materials for the infrastructure of North Carolina today and tomorrow. And I learned this while exploring North Carolina.
This program is made possible by the North Carolina Aggregates Association, with programs to improve public understanding of mining and the use of mineral products.